We are in civil SHM since 20 years, and fortunately our business picked up a lot in the last 2 years. So we have projects now from Chile to northern Siberia, from Canada to New Zealand. And I would like to show you 2 cases, one from Turkey and one from Taiwan. In our process, we have made the transition from structural health monitoring to structural health management. We still do monitoring, of course. Then we have this big data thing where we have 25 terabytes in the database. We identify the system, we make a risk analysis, and with that, we give decision support, and it's very much related to money also. Some of the things are in the book in English and in Chinese. The first example from Turkey, this is not Turkey, but construction accidents happen. So monitoring the construction process makes sense. In the Izmit Bay Bridge, there is a viaduct, 1,300 meters long, 30,000 tons of steel. We have to push it upwards 3.5%. And it's a very slender structure, as you can see here, and 130 meter span of pushing is also extraordinary. So this process itself is well known, but how does the structure behave? It was decided to implement a monitoring system to watch what's going on. We watch many indicators and look where the problems are, and I would like to show you only a few small things. Here you can see how big the size of this structure is. The bottom plates are 80 millimeter thick. In the picture to the left, you see only a small part of the whole system. You see the traffic light, which is our indicator. This is what our client sees. We have monitored some of the sections, a particular displacement, and we see how the bridge behaves under these changing conditions. You know, it is pushed over piers, so we have cantilevers and we have displacements. And we had one case where there was a red indicator. This means we have thresholds. One threshold is yellow. This is indicating something's happening. These are the engineers and the workers involved on that. You see the size of the project. We were able to show that nothing went wrong. It was just a mishappening in operation. The other example from Taiwan, again, you see the traffic light, which is the indicator for the client. High-speed train running on viaducts. One of them is instrumented. You see a typical signal, a train coming. It shows us how much displacement such a train introduces to the structure. You can see it here. Every axle is represented. And fortunate or unfortunate, we have experienced an earthquake of magnitude 6.4 2 years ago. It was recorded. This is the same place. It is the same sensor, which I show here. You see the earthquake arriving, the P wave. It changes to yellow. There is something going wrong. After 12 seconds, the S wave arrives. You see the amplitudes increasing considerably. So the indicator gets red. Trains are stopped immediately. This is a difficult exercise, but the earthquake itself lasts 20 seconds. After these 20 seconds, everything goes back to normal, more or less. But our procedure is continuing to evaluate the whole thing. It's still kept red because we don't know whether there has been some damage. And then we have an indicator 3 hours. After 3 hours, we have to open the stretch. So when the countdown goes to 0, we have to be sure that everything is fine. In this case, it goes back to green. Very successful application. Here, the trains can run again. So how does it work? Real-time decision support. We have a standardized condition index already with some uncertainties. We have an impact. We have a residual loss in our condition. And then we can predict the further lifetime of the structure with uncertainties, and we have to reduce them within 3 hours to reasonable limits. These are success stories, and the next challenges are coming up, 500 tons on a small bridge. Thank you for your attention.
Thank you very much. Thank you for